Yeah, thanks, Johannes, for giving this opportunity. It's really pleasure to be here in the morning and usual Delhi day morning, right? Very cold, very polluted, I guess. Anyways, back to the point. So we are an enterprise workbench. So enterprise workbench for deep learning to develop and deploy high-scale AI systems on a large data sets. So we are a team of researchers of about 15 people, researchers from IIT, ISA, ISER, and from all over the world, more or less. And then we have a strong enterprise-focused business team from who has worked in companies like BNP, Sun Microsystems, Infosys, primarily with a lot of US background. Our mission was to develop tools that can simplify complex AI tasks. So we believe everyone wants to use AI, right? So AI is going to be transformational technology that's going to change whatever we look at. The complexities in terms of any business, any company, or any startup, or even any developer facing today is how to build such kind of AI systems. Everyone understands the requirement and the importance of it, but the problem is the path to the solution. So that's why we believe that if we could able to simplify the process, we can see a lot of people developing their own AI systems, not just using something what someone else has built. Everyone has his own requirements, so then they want to customize it, they wanted to train it, and then they want to build their own IP differentiator level systems, right? So that's the kind of space that we are in. We wanted to simplify the complexities such that we can see everyone building their own AI. And some of the mentions has already been mentioned. So we have been named Forbes 30 under 30, and we are also nominated for International Innovation Award from French Innovation Agency. And then we also have been named for top 4 next generation technology startups from Silicon Valley Forum. Yeah, so the question, when the question comes how to build AI, right? So typically there are 3 fundamental processes that you can look at. One is rule-based system, and then the second 2 are supervised or unsupervised learning systems. Currently, any AI system that you're looking at today is either ML system, machine learning, traditional machine learning, or even normal NLP-based systems. This is a next generation phase where we can be seeing more supervised or unsupervised learning systems. For example, Microsoft speech recognition, right, which has achieved near to human level accuracy. That's only because of deep neural networks. So usually in rule-based system, you define a rule and the system will use that rule to interpret the data. In supervised learning system, you just give an example and the system will write its own rules in terms of understanding the problem. In unsupervised learning system, you just give the data and you just give the problem statement and the system has to figure out its own path to be able to achieve to that task. So these are the 3 classic systems that you can build AI. Rule-based system, again, as I said, is classic ML, statistical, and normal NLP-based systems. Supervised and unsupervised is where there is a lot of progressive advantages. Deep learning is a key technology where you can start imagining that kind of systems. So when it comes to the problem statement, as I said, so deep learning is fantastic. So deep learning works everywhere, irrespective of the data sets. If you have text-related problem, image-related problem, statistical-related problem, number-related problem, you can still use deep learning. But the problem is the path to an application, right? So deep learning system is a very complicated process of building the application. It needs different kinds of hardware. It needs different kinds of research level expertise. It needs different kinds of DevOps. It needs different kinds of admin level systems. This is a classic problem that every enterprise faces. And many of the enterprises has a large quantum of data, and they have a huge set of requirements, huge set of paths for AI adoption also. But the problem is how to achieve that. So this is what our key focus is, to be able to simplify the complexities in building an AI system so that every enterprise can start imagining their own application. So the 2 key products that we have is Vega and Braid. So Vega is a workbench and Braid is more or less a new coding language for deep learning. So we wanted to simplify, as I said, either through coding interface or a normal level interface. So using Vega, you can actually build very complicated neural networks in a very short amount of time. Irrespective of whatever the complexity is, you can actually build or imagine a deep learning system by just drag and drop the neural layer that you wanted to create, and then create a high-level architecture, and they can say deploy. So the system automatically chooses its requirements and deploys on a defined data set, and also in the infrastructure. Vega uses GPUs, graphic processing units, or high-scale processing units, and then you can actually plug and train your data set. For example, you might be storing your data in Hadoop clusters, or you might be storing your data in traditional databases, right? SQL, MySQL, MongoDB, whatever the databases are. You can still connect that databases to the platform, and you can stream the data. And after streaming the data, you can train the network on your data sets. And scaling and deploying is very much easier, is very much automated, more or less. So most of the admin tasks are automated such that your task as a developer, as a researcher, is just to define the network and just to define the data source. So everything happens more or less in an automated manner. So this platform itself is heavily customizable. So we offer multiple toolkits, multiple tools specific to use cases, such that you don't need to start from scratch again and again and again. And besides that, we also have modules in the sense the networks, which are related to multiple problems, like memory networks, image classification problems, risk segmentation kind of modules. We have multiple modules, so you can just take the platform and activate the module that you want, and you can start plugging your data and start building the networks. So yeah, the other big problem that we look at is building a single functional, multifunctional platforms, right? So usually the platforms are always data-dependent platforms. Like many of the analytics platforms are heavily dependent on number-related data, or text platforms are related on text-related data, image are related to image. So, but as I mentioned, so the use case of deep learning is multifunctional or multivariable, right? So instead of investing in a new platform again and again for certain use cases, we believe enterprises always looks for a single platform that can be applicable to multiple use cases. So then they don't need to invest or reinvent the process again and again. They can start using the same platform for multiple level use cases. For such reasons, Arya can be applied for multiple tasks, not just limited to one or two. App intelligence, predictive analytics, intelligent IoT, security, autonomous vehicles, process automation. Irrespective of whatever the tasks are, we can still use the same platform. So adoption. So in fact, in the past 6 to 7 months, we already have been working with multiple Fortune 500 companies deploying the platform for various amount of use cases, not just limited to any segment or any vertical. Even though banking and finance is kind of biggest vertical at this point for us. Besides that, we already are working with multiple people in aviation, automotive, retail to some extent. But these are the few use cases that we already have worked with. For example, in insurance, right? So this is one of the more recent use cases that we already have worked with one of the biggest reinsurer in the world. So claim assessment and automation. So using satellite images plus your previous data sets. So people wants to automate the underwriting process. People wants to automate the claim assessment in insurance industry. Even though the agenda was there for a very long time. So we kind of now building a system that actually automates end to end, more or less from your claim automation and underwriting automation and even risk automation, right? So all three aspects in a single solution. In banking, so the use cases are multiple, from advanced analytics to automation to assistive systems. We actually have deployed multiple use cases in banking industry. And then in medicine, radiology level analysis, even though this is one of the oldest problems that we solved. So you can actually give a report that you have, and the system can start analyzing the information in a milliseconds amount of time, still using very small amount of server. So these are the few use cases that we already have deployed the platform in. Yep, so we believe deep learning going to change a lot of things in the future, and we wanted to be the catalyst of the change, in the sense, no matter what the use cases are, you can still use the same platform. And we have been working with multiple people, and we've loved to work with high-scale industries in terms of bringing high-skill and very advanced level products into an existence today. Thank you very much.